Hello everyone, welcome to the lesson on tuples, which is part of the course Python programming. In this lesson, we will discuss the fundamentals of tuple data structure and explore how they are different from the list data structure which we learned earlier in the course Python for Beginners. If you have not followed the lesson on lists, I highly recommend following it before this lesson since it will help you understand the content better. This is the color coding we'll be using throughout this lesson. This lesson is structured as follows. We will start the lesson with an introduction to sequence data types and tuples. Next, we will discuss how to create tuples and access values in them. After that, we will briefly look at tuple packing and unpacking. Then, we will talk about insertion, deletion, and update. We will also compare tuples and lists. Finally, we will look at some tuple operations and conclude with a summary. Further, throughout this lesson, we will look at several examples and exercises that will help you understand the content better. Let us start with an introduction to sequence data types. What are sequences? A sequence is an ordered collection of elements. We call them ordered because the elements will be maintained in a specific order and the order will not change. Consider the following example. We have a variable with the string computer. Then we create a list with these letters. When we print the list, we can see that the list keeps the elements in the same order as the input. Next, we create a set, which is another data type in Python with these same letters. When we print the set, you can see that the letters are in a completely different order. Therefore, we categorize list as an ordered data type and set as an unordered data type. Three basic sequence data types in Python are list, tuple, and range. In our first course, Python for Beginners, we learned about the list data structure. In this lesson, we will discuss the tuple data structure, which is very similar to lists. The first topic we are going to cover is the structure of tuples. Tuples contain comma-separated values between round brackets or parentheses. The only difference from lists is that the square brackets in lists are replaced by parentheses. This is a sample tuple in Python. You can see that the values are comma-separated and are within parentheses. Even though we say that tuples contain values within parentheses, parentheses are not mandatory when creating a tuple. We will see an example in the next slide which will illustrate this idea clearly. Similar to lists, the values within a tuple need not be of the same data type. Now, let us look at a few examples to understand what we discussed in the previous slide. In this line of code, we are creating a tuple with 4 elements. It is important to note that the first 2 elements A and B are strings, 20 is an integer, and 4.1 is a floating point number, which are all different data types. You can check the data type of a variable using the type function. If we call type with tuple 1 as the input parameter, you can see that it outputs tuple as the data type. In the previous slide, we mentioned that it is not mandatory to have the parentheses when creating tuples. Here, we have another variable named tuple2, which contains the same set of elements as tuple 1, but without the parentheses. If we print tuple2, you can see that the system has added the parentheses by itself. If we check the data type of tuple2, it is indeed a tuple. A tuple with a single element is a special case. Let us see why. The variable tuple3 contains one element, which is string A, inside parentheses. If we check the data type, it turns out to be a string and not a tuple. So, how do we create a tuple with a single element? We should include a comma after the element as shown here. If you check the data type of the variable tuple4, you can see that it is a tuple and not a string. Now that we know how to create tuples, let us look at how to access values in a tuple. Accessing values in a tuple is similar to lists. Consider this tuple that contains 5 elements, 15, 20, 96, 32, and 17. The first step is to create the tuple. We code my tuple is equal to, within parentheses, 15, 20, 96, 32, 17. The parentheses are optional. Similar to lists, tuples are also indexed starting from 0. Hence, when we call my tuple within square bracket 0, it will output the first element in the tuple, which is 15. Similarly, if we want to access 17, which is at index 4, we call my tuple within square brackets 4. You can see that we get the expected output, which is 17. The next subtopic is accessing values using negative indices. This also works similar to lists. We have learned in course 1 that in negative indexing, the last element is indexed -1 and the values are indexed from right to left as shown in the diagram. Let us look at a sample code. As always, we create the tuple first. Then, when we call my tuple within square brackets -1, we get the last element 17 as the output. Similarly, using -3, we'll return the element at index -3, which is 96. The next subtopic under accessing values in a tuple is slicing. You are aware at this point that slicing means extracting a part of a sequence, which in this lesson is a tuple. Slicing is exactly the same as what we learned in the lesson on lists. Let us consider the same tuple here as well. First, we create the tuple. What will happen when we call my tuple with the range 0 to 3? It will output the values from index 0 to index 2. Remember, if the range is from m to n, the values considered will be from index m to n-1. Therefore, the output will contain 15, 20, and 96. Similarly, if the range is from 2 to 4, the values at indices 2 and 3 will be outputted. The final subtopic under accessing values is nested tuples. Nested tuples are similar to nested lists. Let us create a nested tuple first. This variable contains 2 tuples inside another tuple as shown here. The first inner tuple contains the values 1 and 2, while the second inner tuple contains the values a and b. Suppose we want to access the value 2. First, we need to access the inner tuple at index 0, and inside that inner tuple, 2 is located at index 1. Hence, we call my tuple within square brackets 0 and 1, where the 0 points to the inner tuple at index 0, and 1 points to the element at index 1 inside that inner tuple. Similarly, if we want to access the inner tuple that contains the values a and b, we know that it is located at index 1. Hence, calling my tuple within square brackets 1 will output the entire tuple at index 1 as shown here. The next topic we are going to discuss is tuple unpacking. Before that, what is tuple packing? Tuple packing is nothing but assigning values into a tuple. In this example, we are assigning the values car, pen, and ice into a tuple. This is called tuple packing. Tuple unpacking is extracting the content of a tuple into variables. Let us look at an example to understand what it means. We have 3 variables, a, b, and c, on the left-hand side of the equal sign, and the tuple my tuple on the right-hand side. We know that the tuple on the right-hand side contains the values car, pen, and ice. What this line of code does is, the content of the tuple will be assigned to the variables on the left-hand side. Hence, the string car will be assigned to variable a, the string pen will be assigned to variable b, and the string ice will be assigned to the variable c. To confirm, let us print the variable b. You can see that it outputs the string pen as expected. One condition when using tuple unpacking is the number of variables on the left-hand side should be equal to the number of elements in the tuple. In our previous example, my tuple contains 3 elements. Hence, we have 3 variables on the left-hand side. Here is an exercise for you to try out. Run the following code and analyze the output. If you get an error message, do not worry, because you are supposed to get an error message. So far, we have discussed how to create tuples and how to access values in tuples. Let us move on to insertion, deletion, and updating tuples. Let me give you a quick exercise. Pause the video and run the following code. See what happens. You ended up with an error message, right? What does the error message say? Type error, tuple object does not support item assignment. Why are we getting this error? What does this error message mean? This is what we are going to discuss in the next slide. You got this error because tuples are immutable. What does it mean? It means once a tuple is created, it cannot be modified. Hence, a tuple does not support insert, delete, and update operations. Unlike tuples, lists are mutable. We learned in course 1 that we can insert, delete, and update values in a list. Let's compare lists and tuples. By now, we know that they are very similar to each other. However, lists are more versatile than tuples. You can update the values in a list and expand or shrink it, but you cannot do any of those with a tuple. On top of that, lists have more built-in functions than tuples. Most of you will be wondering, aren't tuples useless since lists have all these advantages over tuples? It is indeed a good question. We are going to discuss this question in the next few slides. Tuples do have a significant advantage over lists. Tuples are memory efficient than lists, which means they consume less memory. Let us look at an example to check whether it is true. Let us create a tuple and a list that contain the same set of elements. Now, let us measure the amount of memory consumed by each of them. We will use a Python function called getSizeOf. It will return the amount of memory consumed in bytes. To use this function, we need the sys module. This line of code will import the sys module that we need. Now, if we run sys.getSizeOf mylist, we get the output 104, which means our list has consumed 104 bytes of memory. Let us do the same for our tuple as well. We can see that it has consumed only 88 bytes of memory, which is 15% less compared to our list. But why? Why do tuples consume less memory? We will not be discussing the answer to this question here, since it is an advanced topic to discuss at this point. However, if you are interested, follow the link provided under Supplement 1, which is available on the last slide. It explains clearly why tuples consume less memory compared to lists. When do we use tuples over lists? If the data need not to be changed in the future, use tuples since it will save a significant amount of memory. If the data needs to be modified in the future, use lists since tuples are immutable. This is the final section of this lesson where we will discuss some tuple operations. We looked at the same set of operations when we were discussing lists as well. The first operation is length, which returns the length of the given tuple. Here, we are calling the length function with a tuple that contains the values 1, 2, and 3 as the input parameter. Since the tuple contains 3 elements, the function returns 3. The second operation is concatenation, which means joining together. Suppose you have 2 tuples A and B. If we want to combine the contents together, we can achieve it using the plus operator. A plus B will output a single tuple with contents from tuples A and B. You can see in the output that the values 1, 2, and 3 are from tuple A, and the values 4, 5, and 6 are from tuple B. The third operation we are going to look at is repetition. Looking at an example will make it easier to understand how repetition works. The tuple here contains the string hi. If you multiply this tuple by 4, the contents within the tuple will be multiplied 4 times as shown here. Note that we are not getting 4 separate tuples, but 1. The next operation is membership. The idea is to check whether a value is available in a tuple. In the given example, you can see that we are using the in operator to check for membership. Statement 3 in the tuple that contains the values 1, 2, and 3 checks whether value 3 is available in the tuple. Since the value is available, it returns true. If the value is not available, it will return false. The final operation that we are going to discuss is iteration. Iteration means going through each element in the tuple one after the other. The code says, for x in tuple that contains the values 1, 2, and 3, print x. How it works is, the first element in the tuple, which is 1 in this example, will be assigned to the variable x. Then, the print x statement will be executed. After that, the second value in the tuple, which is 2, will be assigned to the variable. The printx statement will be executed again. This pattern continues until the last element in the tuple. Let us quickly summarize what we have learned in this lesson. Tuple is a sequence data type, which means it is ordered. Tuples and lists are similar to each other in many aspects. For example, in their structure and how the values are accessed. Tuples are immutable, which means they cannot be modified after creating them. Tuples are memory efficient compared to lists. Finally, tuples contain many useful built-in functions. We have reached the end of this lesson. I hope you enjoyed learning about tuples.